Rudolph, the red-nosed reindeer, had a very shiny nose. In fact, a lot of reindeer have red noses. Seriously, that part of the song is accurate. But why is that? On this festive episode of the Oxford Sparks Big Questions podcast, we are asking, why is Rudolph's nose red? Hello, I'm Emily Elias, and this is the show where we seek out the brightest minds at the University of Oxford and we ask them the big questions. And for this one, we've found a researcher who's willing to step outside his normal scientific comfort zone for this very special Christmas episode.
Hello, my name is Ignacio Juarez, but please call me Nacho. Everybody calls me Nacho. I am a PhD student at Penguin Watch, a research group based at the zoology department in the University of Oxford. And I study penguins and penguin ecology and how climate change affects them.
Okay, so we've come to you for not quite a penguin story. We're actually looking for this big answer this holiday season of why is Rudolph's nose red? I mean, Nacho, what is going on with reindeers' noses?
That is a fantastic biological question, actually, because vertebrates in general, and Rudolph is a mammal, so therefore a vertebrate, cannot produce red pigments. So how could Rudolph have an actual red nose, like bright red? So there are actually two ways in which Rudolph could have a red nose. And the first one is the same way that, for example, flamingos get their red color, or king and emperor penguins get their orange patches, or I don't know, if you're thinking of North America, cardinals, they are all completely red and they're also vertebrates. How do these animals get that red color? So all of them get their color from eating, for example, flamingo, they eat little crustaceans. If you think crustaceans are like prawns, so orange. So by eating orange, the cardinals and the birds, they get them by eating, for example, red berries. And they incorporate these little colors into their feathers and or their hair or whatever their pigments are. And that constitutes what in biology we call honest signaling. Honest signaling is a way of an individual to tell their partner or their possible partners, hey, look how well fed I am. Look how well I eat my veggies. Look how well I get all of the food for myself. And if I am so good at getting food for myself, I will surely be a great partner to bring back food to the nest or to the den or to the burrow or wherever. And so one of the options would be that Rudolph actually has his red nose from eating a lot of veggies.
So that's one possible reason that Rudolph is the healthiest reindeer out there, but there's another reason you said. What could that be?
So the other reason is that if you think about it, vertebrates, we can produce one red pigment, and it's the one that is in our blood. That's hemoglobin. So the other possible reason is that actually the reason why Rudolph's nose was red is because it's just full of blood. But actually, that doesn't make a lot of sense to have, a bright red nose full of blood in such a cold environment, especially going at the incredible speeds that Rudolph goes. So how could this be? And the answer could actually be, sorry to bring this back to my to my field, penguins and other animals adapted to living in cold conditions. So this is the same answer for how do penguins' feet do not get cold, and their flippers and their noses when they're breathing in and out frigid air. So the answer is the wonderful network, or rete mirabilis, as it was initially called in Latin when this was discovered almost 2,000 years ago. And what happens, what this awesome network is an awesome network of capillaries, of blood vessels going in and out, in case of Rudolph, in and out of their nose to give this bright color. The way this awesome network works is by putting capillaries, so blood vessels, very close to each other. The blood vessels that are coming out with warm blood, they need to be cooled down before they reach the outside to not lose the temperature. And the cold blood through the inbound vessels needs to get warmed up before bringing in that cold to the body of the reindeer, and because that could cause hypothermia. So what the rete mirabili does, what the ozone network does, is that it puts the cold and the warm vessels together, very fine vessels, very, very, very close together. So the warm blood gets cooled down before going out, and the cold blood gets warmed up before going in.
Can you explain to me a visual way?
Yeah, more visually, this would be something like imagine that you are coming out of a metro station out of the tube station, and you see that you have the escalators going up and the escalators going down. You wouldn't want the people going out to get cold. So one thing that could happen is that the people coming in from the cold and are going into the tube, that they don't need their coats anymore, could be able to hand over their coats and their jackets to the people that are going outside. And for that to happen, for that to protect the people going outside with the coats and be able to reuse the coats, let's think that this is all collaborative, this is all within one organism. To be able to hand over the coats over the escalators need to be very close to each other. And this is like many escalators going up, intertwined with many escalators going in, and that is what this awesome network is.
So this awesome network or wonderful network, I guess the names are interchangeable.
Yes.
We have this in penguins, and we apparently have this in reindeers' noses, possibly explaining why Rudolph's nose is red. Do any other animals do this?
Yes, this is very common, and this is something that has evolved separately in many species that have had their ranges expanded into colder territories. Like this is something that we see, for example, in the noses of the polar bears, to be able to breathe out colder air rather than breathing out their temperature away. This is something that we find in sharks, in gills of many fish that live in cold temperatures. This is something that we find in all throughout the animal kingdom, in many, many, many animals whose species distribution has ventured into the polar regions.
And us humans, we don't have it, because if I was to stand on a block of ice like a penguin does, my imagination is that I would just get hypothermia.
I think you would get hypothermia pretty quickly. I think under 20 minutes you would be needing of a very, very big warm soup.
So, Rudolph the Red-Nosed Reindeer, the song that goes along with the history, or I guess the folklore of Rudolph, that also has some truth in science?
Yes, I mean, because there is in the song, you hear how the other reindeer used to call him names just because of being different. But actually, it is that difference. It is that bright red light that saves the day, that saves Santa on his flying through the skies and guiding him. So he's the one that saves in names and ends up being praised. And that has a big correlation with biology and evolution. Biology in general creates a diversity of organisms to make sure that each species has all of the possible solutions that they could need to move on to the next generation. And if I wanted to make this point, is because especially with kids, there is so many of them that are being called names for being different. And I think just from the point of view of biology, that if you're ever called names for being different, don't worry. That means that you have capabilities that no one else has. That means that you're literally extraordinary, and that your capabilities will help you save the day someday.
Nacho, can I ask you something a little bit off topic? Could a polar bear open a bottle of cola?
That is actually a great question, because the thing is that polar bears are part of the plantigrade family. And plantigrade, literally in Latin, means that they walk by resting their weight on the palm of their hands. And what this evolutionary has meant for them is that all of their fingers are pointing forward. So none of their fingers is what in biology we call opposable. That means like your thumb, that, with your thumb you can touch the tip of your other four fingers. Polar bears cannot do that. And hence they cannot really grab anything. And because they cannot really grab anything, they cannot grab a cola. So polar bears do not get cola for Christmas.
And I guess they can't also share them with penguins.
And yes, and definitely one of the things that they can never do is to share their cola with a penguin, not only because they cannot grab it, but because polar bears live in the Arctic, which literally means bear, and penguins live in the Antarctic, that literally means opposite to where bears live.
This podcast was brought to you by Oxford Sparks from the University of Oxford, with music by John Lyons, and a very special thanks to Nacho Juarez. Spread some festive cheer, why not? Rate and review us on whatever podcast app that you use. That would be a great gift for us. Or go find us on the internet and tell us what you like, what you don't like. If you've got a big question, we're all ears. We are at Oxford Sparks, or go to our website, oxfordsparks.ox.ac.uk. I'm Emily Elias. Bye for now.